Hello, and welcome to Astronomy 100. In this video, we're going to continue our discussion of the Moon. And in the previous video, we talked about some of the surface features that you see on the surface of the Moon. And in the video, we talked about how the craters, these holes in the surface of the Moon, were rather interesting and a bit perplexing to early scientists. But now we know that the majority of the impact craters on the surface of the Moon are caused by objects from outer space that are slamming into the surface of the Moon. We also learned that the Earth has impact craters as well, and we visited a very famous one outside of Winslow, Arizona, and we saw a really nice tour of that one. In this video, we're going to continue to discuss impact craters and talk about why the Earth has impact craters as well, and some of the features to the craters, as well as other solar system bodies that have craters too. So let's go ahead and get started. The surface of the Earth has lots of craters. Some of these craters are volcanic in origin, but about 200 of these craters on the surface of the Earth are caused by impacts, objects from space slamming into the surface of the Earth. And here are just a sampling of some of those, nearly 200 impact craters. Now, the one in the upper left is from Namibia, and it is a crater that is about 4 million years old. And the crater is showing some signs of erosion. You can see that over time, wind and rain has slowly started to make this crater disappear from the landscape. This one here on the right I chose because it's a view taken from space. Once humans had the ability to go into space and see the surface of the Earth from high above, we started to discover impact craters because the view from space shows us things we can't necessarily see from the surface. The people in South Africa that live in this community or in this part of the world thought it was just a very large mountain chain off to one side, but you can see that from space it has all the hallmarks of an impact crater. It has the slumped sides that are very typical, where part of the edge of the crater has collapsed in on itself after its formation process. These two pictures down here are both from Canada. This one here is called Clearwater Lakes in Canada. And on the ground, it is simply two lakes next to each other with an interesting island chain in the middle of one of them. But what you can see from space is that these are both impact craters. And it's believed that the object that slammed into the surface of the Earth broke into two pieces before hitting the ground, creating the double crater that you see here. And again, the interesting island chain in the middle of this lake is actually the central peaks from the impact crater that is very common for very large craters. This one here on the lower right, this is Manicouagan crater. It's a Native American name. And on the ground, it seems like a very, very odd circular lake, or you could think of it as a lake with a very large island, one way or the other. But from space, you can see that it's easily recognizable as an impact crater. And this one is a very old crater, and it has the weathering process that has started to erode it and slowly make it disappear. So the question is, why is it that on the surface of the Earth we have very few craters, less than 200, but on the surface of the Moon there are countless numbers of craters? The reason simply is the factors that are involved in what the Earth has to experience that's different from the Moon. For instance, on the Moon there is no air. And if there is no air, there is no wind, there's no rain, there is no normal weathering that would erode craters, causing them to slowly disappear over time. The other feature is that on the Moon there is no geologic activity. On Earth, we have the movement of the plates, we have the geologic process that continuously renews the surface of the Earth, and over a long period of time, any craters on the surface of the Earth would get renewed or erased due to geologic processes. On the Moon, there is none of that. On Earth, the atmosphere that we have will serve to burn up many of the small objects that would normally hit the surface of the Earth. If the object is small enough, the heat of the re-entry of the object as it passes through the atmosphere will burn up and disintegrate the small body. And on the Moon, without an atmosphere, no matter what size the impactor is, big or small, it's going to leave a crater. So the Earth has a protective layer of atmosphere that shields us from small things. And so all of these features will combine to make it so that the Earth has the ability to erase its craters over time where the Moon does not. So it is believed that the Earth has been hit many, many, many times, but of course has the ability to slowly erase those impacts where the Moon does not. And the Moon is simply showing us an entire history of impacts all over its surface. And so it's just clear that there's two different processes, even though both objects, the Earth and the Moon, have been hit over and over. In our solar system, there's evidence of cratering that occurs as well. Just about every solid body in our solar system shows a history of being hit by objects from outer space. Let's take a look at a few. I have a few samples here. The one in the upper left is the planet Mercury, and you'll notice that Mercury in many ways looks an awful lot like the Moon. It has lots and lots of craters. It is the same color as the Moon, solid rocky body like the Moon, but you can see that Mercury, like the Moon, has been hit many times, countless numbers of craters all over its surface. This moon here in the middle of the screen, this is one of the moons of Jupiter. It is called Callisto, and it is one of the 4 large moons of Jupiter, and it is also covered with many craters. The difference here is Callisto is covered with a surface layer of ice, and the objects that hit the surface of Callisto will create craters in the ice. So you'll notice they look white in appearance, almost like shattered glass. This one I threw in because it reminds me of one of my favorite science fiction movies. I'll let you guess which one that is. But you can see that this moon called Mimas, which is one of the moons of Saturn, has a very large impact crater, and it has a central peak to it. The moon itself is not very big, but the crater is actually large relative to the size of this moon. So this was a very big body that hit this moon, creating this crater. This is the planet Mars, or at least part of it. And I like this picture because you'll notice that, first of all, you can see that Mars has lots of craters. And the reason why Mars shows many more craters and the Earth does not is Mars does have an atmosphere. You can actually see that in this picture. So this thin layer right here on the edge is the atmosphere of Mars. But the atmosphere is much more thin, and so it doesn't have the ability to stop objects from hitting the surface of Mars. Also, Mars is geologically dead. There is no liquid water on its surface anymore. There is a lot of wind, but there's no rain to erode these craters. So Mars will show a history of cratering as well. These last two down here are asteroids. The one difference, though, is the one in the middle, Phoebe. This is an asteroid that has been captured by Saturn. So it is technically one of the moons of Saturn. But you can see that this asteroid that has been captured, it has lots of craters all over its surface. Over here in the lower right, this is the asteroid called Eros, and although it has a very odd shape to the asteroid itself, it is again covered with craters. So it's very clear that in our solar system, the solid bodies have a rich history of being hit by things. And the reason why this is because in the solar system, in the early days of its formation, there were many, many different little objects that were swarming around the sun. Some of these smaller objects were able to come together to slowly become the planets themselves, but a lot of the smaller bodies that orbit around the sun that never were able to become the planets or the moons of the solar system continued to move around the sun. And so all of the solid objects in our solar system today are still being hit by this leftover debris. On any given night, you can go outside and witness these what are typically called shooting stars or falling stars, which neither of one are related to stars, but these are meteors that are small pieces of rock that are entering the Earth's atmosphere on a regular basis, and we still see this happening today. So the scientists of the 20th century started to piece together all of these details, and what they soon realized is that the moon itself is formed from an impact. And the reason why we know this is because the scientists of the 20th century wondered how could the Earth have a moon when Mercury does not have a moon, Venus does not have a moon, Mars has 2 small captured asteroids, so essentially doesn't have a moon like the Earth's. And so why would the Earth have a moon where the other planets of the inner solar system do not? One of the leading theories that came out in about the 1960s is that our moon formed by the process of the Earth being hit by another body when the solar system was very young. And so the current explanation, based on the evidence that we have, is that the Earth suffered a collision when it was about 100 million years old, and the object that slams into the Earth created debris that ultimately becomes the moon itself. Now what I'm going to do is I'm going to show you a video that will chronicle how this occurred. The video is about a minute long, and I'll talk our way through the video and show you how some of the details of this are. But this video will show you this process. So here we go. In the early solar system, we had the early Earth moving around the sun as a newly formed body. Off in the distance is another object that happened to have an orbit that crossed the orbit of the Earth. And under the right circumstances, we had the two bodies collide. Now the impact by this other body hitting the primitive Earth created a major impact, of course ripping off a big part of the outer layer of the Earth's crust. The debris that goes into space would orbit around the Earth. It was given a lot of energy, so it goes off into orbit. And for a time, this debris created a ring around the Earth. Imagine the Earth with a ring. Now, gravity over time is going to slowly bring these pieces closer and closer together. And you can see in this video that the pieces are slamming into each other. And as the pieces slam into each other, they slowly start to form bigger and bigger pieces. Eventually, all of these pieces would gather together to make the one single object that we today call our moon. And this process took probably on the order of several years to slowly sweep up all of the debris to create the moon that we see today. Now what I want to do is I want to go back to one little portion of the video here because there's something that is portrayed that needs a little bit of explaining. Once the moon was formed into the body that becomes the single object that orbits around the Earth based on all the debris being swept up. What you'll notice in the video is they show the distance between the newly formed moon and the primitive Earth will suddenly grow. And we'll pause it when this happens here. So notice how suddenly the Earth becomes very far away. This portion of the video is describing something that we now know about the moon. It turns out the distance between the Earth and the moon is steadily growing over time. What that means is the moon is drifting further and further away from the Earth every moment of every day. Now, the way that we know that this is true is because the Apollo astronauts in the 1960s and early 70s, they left reflectors on the surface of the moon. And these reflectors were meant to send light back in the direction that the light comes in. Think of a reflector on the back of a bike. And so what happens is, on a regular basis on the surface of the Earth, we have very powerful lasers. And these laser beams are shot towards the moon, and the light reflects off of these reflectors and is reflected back to the Earth. Since we know the speed of light, we time how long it takes the light to go to the moon and bounce and come back, and we can actually figure out the very precise distance between the Earth and the moon. And for the last 40 plus years, we have been steadily measuring that distance growing over time. The moon is drifting away from the Earth at a rate of about 1.5 inches per year. So every year the moon is about 1.5 inches further and further away from the Earth. Now there's a complicated explanation as to why this is occurring. The only thing I'll say at this level is that there's a gravitational interaction occurring between the moon and the Earth that is causing the Earth's rotation to slow down, and it is also forcing the moon to steadily move further and further away. So gravity between the two bodies is making this happen. Now eventually the moon will reach a maximum distance and will not get any further away. In other words, the Earth is not going to lose its moon. It will reach a maximum distance where its orbit will still be around the Earth, but the Earth will spin very slowly while the now very distant moon orbits around the Earth. So this is something that's going to take a very long time. In about 4 to 5 billion years, this process will reach its end. The moon will be at a maximum distance. So what we now know, based on the evidence, is that the reason why the Earth has a moon is because of an impact that the primitive Earth suffered about 4.5 billion years ago. And we can sort of confirm this because when the astronauts brought back the materials from the moon, from the Apollo missions, the rocks from the surface of the moon showed us that they were very similar to the crust of the Earth. And so anything slamming into the crust of the Earth, ripping off that material to slowly become the moon, the moon is now going to be made out of that same material. The other thing is that the rocks that they brought back from the surface of the moon are lacking lots of water, very dry rocks. And so the impact process would have superheated the rocks and made all the water disappear. And so many different features about the moon can prove that it is definitely a product of the Earth, and the best explanation seems to be that the Earth was hit by an object. Lastly, the age of the moon is about 4.5 billion years old, which is about when we expect that this impact occurred. So very interesting. Now, in the next video, we're going to talk about how we see the moon in the sky over a period of time, and we will eventually describe the phases of the moon, and we'll talk about that in the next video. I hope you'll join me.